Hello everyone. This video is the second in a three-part series to demonstrate how to use the CyCon Life Cycle Assessment tool. In this video, we will be conducting a simple economic life cycle assessment of a hypothetical public transit system. To start, let's revisit our scenario. This map depicts a residential area where 100 inhabitants work in one of four locations indicated by their color. Each of the green diamonds represent a bus stop in the proposed transit system. Our goal in this assessment is to compare the annual cost for each of the residents to drive a personal vehicle to work, to the annual cost of running a diesel bus on this route, and the annual cost of running an electric bus on this route. Let's go over our key assumptions for this scenario. So first, the key assumptions for the cars. Firstly, a new car costs $30,000 and has a lifespan of 8 years, which comes out to an average of $3,750 per year. Next, fuel and maintenance costs 25 cents per mile traveled. And finally, cars will drive their route 2 times a day for 260 days. For the diesel bus, we are assuming that a bus costs $450,000 and has a 12-year lifespan, which comes out to $37,500 per year. Next, fuel and maintenance will cost $2 per mile traveled. The bus route will take 1 hour to complete, and the bus will run for 10 hours a day, 260 days a year. And finally, labor will cost $23 an hour to operate the bus. For the electric bus, the assumptions are very similar to the diesel bus. However, the big differences are that the bus costs $700,000 instead of $450,000, and that the fuel and maintenance cost will come out to about 92 cents per mile instead of $2 per mile, like with the diesel bus. Now that we understand the key assumptions for our scenario, let's go over the workflow for how we will calculate the annual cost for the car, the diesel bus, and the electric bus. To calculate the total annual cost for the cars, we will start by finding the annual operational cost. First, we'll find the total sum of distance traveled by all workers in one trip measured in miles. Then we multiply that value by 25 cents per mile for fuel and maintenance. Then we multiply that by 2 trips per day for 260 days per year to find the operational cost per year. Next, we'll find the capital expense for the 100 residents to each purchase a new car. We do this by multiplying $30,000 per car by 100 cars per 12 years. The resulting value is the average cost per year for a new car. Finally, we add together our operational costs and our capital costs to get the total cost per year for our residents to purchase and operate a car. To calculate the total cost per year for a diesel bus, we will first find the annual operational cost. We do this by multiplying the length of the bus route measured in miles by our assumed cost of $2 per mile for fuel and maintenance. Then we multiply that value by 10 trips per day for 260 days per year to get our annual operational costs. Next, we find our capital costs by dividing the $450,000 price of a diesel bus by the expected 12-year lifespan to get an average capital cost per year. Then, we calculate the annual cost of labor by multiplying $23 per hour by 1 hour per trip or route, multiplied by 10 trips per day for 260 days per year. Finally, we add the operational costs, the capital costs, and the labor cost to get the total annual cost for the diesel bus. The workflow for the electric bus is almost identical to the diesel bus. The only differences are that we are assuming a cost of 92 cents per mile in the operational cost as opposed to $2 per mile, and that the capital cost is going to be $700,000 across a 12-year lifespan instead of $450,000. Next, we'll look at how to use the CyCon Life Cycle Assessment tool to compare the annual costs of all 3 vehicle types. To get started, we'll enter in our project name, as well as our goal and our scope. Next, we'll add data to our life cycle inventory. Click Add Process, and we'll select the car distances data set, which gives the distances that all of the workers are traveling. Then we'll add a process for our diesel bus using the bus distances data set, and we'll add a process for our electric bus using the same data set. Next, we'll go through and rename all of the processes. Now we can enter the formulas for our different processes. Now that our formulas are all written, we can scroll down and click Perform. If we scroll down to the Results and Interpretation section, we can see that the annual cost of car ownership for all of the workers comes to a total of $390,083. The total annual cost for the diesel bus is $141,130. And the total cost for the electric bus is $138,295. Thanks for watching. In the next video, we will be demonstrating a simple social life cycle assessment using the same scenario.